Hi everyone, so in this video we're going to be talking through some absolute basics of the calculator. I'll be using the TI-Nspire CX2T, which you'll also be using. The absolute basics, the most important thing will be graphing and the different things you can do graphing on the calculator. So when you first open up the calculator, you'll have a screen that looks something like this, which is on my screen at the moment too. Generally, we would advise you, instead of using the scratch pad, to use one of these 7 icons along the bottom, because it'll make it easier to save your work, etc., etc. So initially, I'm going to use the graphing symbol, which is this second symbol here with the little graph. Okay. Let's say, for example, I'm doing a question and the function that I want to graph is f of x is equal to 7x squared minus 4x minus 1. Okay, the first thing that's worth mentioning, so when you open up your graph, you have something that looks like this, and up in the top here you have the toolbar where you can type in the function that you need. You must always type your functions in terms of x. So in this case, I have got my function defined in terms of x. If it's defined in terms of some other variable, t, g, z, whatever it might be, you must always use x when you're graphing the function on your calculator. So I can simply type in 7 times x squared minus 4x minus 1. Okay, and I hit enter over here and my graph appears. There's various properties of graphs that you may wish to calculate. The first sort of obvious things to think about are the intercepts. So the y-intercept, well, we can see that maybe looking at the function. If you're not sure, you can substitute 0 into your function. You can also hit Control and T, and it will open up what we call the table of values. So for integer numbers of x, which we've got listed down here, it will just list the y values. Obviously, if I'm interested in the y-intercept, I'm interested in the y value when x is 0, and I get minus 1 as expected. If I want to close this table and see my graph a bit more clearly, I can just hit Control and T again. Okay, the other things we might be interested in are the x-intercepts, or the roots, or the zeros. The first thing I'm actually going to do is just adjust my zoom slightly. So I'll go to Menu and then Window Zoom. I have various zoom options. They'll become useful at different moments in time. For the moment, I'm just going to use zoom in, and I'm just going to zoom in on this function. Oh, perhaps a little too much. We'll zoom out. Just so I can see the roots slightly more clearly. Okay, so I'm going to click on Menu, Analyze Graph, and then 0. My zeros are my roots. And then you'll notice that along the bottom, lower bound is shown. That's because I have more than one root in this graph, and my calculator needs to know which one I'm interested in. So I need to select the lower and upper bound of the region that I want it to look in for the root. So for the lower bound, I'm going to look at the left-hand root to begin with. For the lower bound, I'm going to click somewhere to the left of it and somewhere to the right of it. And we can see that the root coordinates are given here. So remember, the point of my roots is I'm solving when this function is equated to 0. I have an output of 0. And my first root tells me that x is equal to negative 0.188. Now I want to find my other root. I'm going to do that in the exact same way. So Menu, Analyze Graph, 0 again. And this time I'm going to select a lower bound and an upper bound that doesn't include the previous 0 that I was looking at. And I can see that x is equal to 0.760 to 3 significant figures. So for solving any type of equation, when it's equated to 0, it doesn't have to be a quadratic. The zeros function is incredibly useful. The other property of this graph and properties of functions in general that we are often interested in are the turning points or vertices. So in this case, it's a local minimum. I can do this in the same way. Go to Menu, Analyze Graph. Analyze Graph is an incredibly useful function. It's got lots of different things on that you'll use throughout the course. At the moment, I'm interested in a minimum. So I hit minimum, and again, it'll find the minimum y value when I give it a region of the graph. So I click somewhere to the left of the minimum, somewhere to the right, and I can see that I have a minimum at 0.286 minus 1.57 approximately. So for finding vertices of graphs, it's also incredibly useful. Okay, that's the properties of a single function. Now let's think about if I wanted to do something a little bit more complex. This will probably be the most useful thing you do on your calculator, solving equations by graphing, not just when they're equated to 0. So let's say instead of just graphing one function, we wanted to solve the equation 7x squared minus 4x minus 1 is equal to x cubed minus x plus 13. Now, by definition here, when they're equal, their x and y values will be equal. So when we equate them, if I substitute in an x value on the left-hand side, I get exactly the same output, so y value, as when I substitute that into the right-hand side. So if I can graph both of these functions, figure out where they intersect, that is my solution. That's when the graphs are equal, their outputs are equal to each other for the same input. So how do I do this? I just need to enter a second function. So I'm going to use the tab key. The tab key is what allows me to enter a second function. You'll notice it sort of hovers a little bit. And I'm going to type in my second function. So x cubed this time, so x to the power of 3 minus x, minus x plus 13. Okay, and I hit enter. And you'll notice that I can sort of see that I've got the graph somewhere, but I can't see if there are any intersection points at all. If we think about the problem, well, it's the zoom. At the moment, on my y-axis, I'm only going up to about 3. This graph, just by sort of sense checking the function, I can see that the red graph, the second function, has a y-intercept of 13. So I could just blindly zoom out. However, if I can inspect the functions a little bit and know how far I need to zoom out or what sort of values I need to include in the scales of my y and x axis, I can do something a little bit more targeted and a little bit more intelligent. So I need to adjust my zoom. I'm going to go to Menu, Window Zoom, but this time I'm going to hit Window Settings. So Window Settings is again incredibly useful. It's what allows me to set the minimum and maximum values of my x and y axes. So at the moment, what I'm really interested in is I know that my y maximum is not sufficiently high. So I'm going to set that to, let's say, I don't know, 25. And I hit OK. And now I can see it zoomed out and I can clearly see the intersection points. So I just need to find what those coordinates are, one here and one somewhere around here, and then I'll be able to find my solutions to the equation over here on the left-hand side. So intersecting graphs, I'm going to go to Menu, Analyze Graph yet again, and this time it's number 4, intersection. Now again, there's multiple intersections, so it's going to ask me for a lower bound and then an upper bound to create a region which includes the intersection point I'm interested in. So I'm going to click to the left and to the right, and I can see that I have my intersection point. If I do the same thing again, Menu, Analyze Graph, Intersection, and I do the same thing on the right, and there I get my other intersection point. I'm interested in my values of x as my solutions, so I can see that my first solution, I have x is equal to minus 1.14, and x is equal to 2. Graphing it visually also helps me check or sense check the number of solutions. So whilst I may be able to solve this algebraically. Why bother on a calculator paper where I can simply graph it, see the number of intersection points and therefore the number of solutions, and just obtain my answers.